Hey everybody, I'm going to try to take a couple minutes and quickly run through this agricultural mitigation methodology. I'm starting kind of at the bottom here because I want to make a point about the importance of these numbers. Everything kind of keys off of these figures from the National Agricultural Statistics Service. These should be the most recent figures, and they have rent expense per acre for irrigated cropland, non-irrigated cropland, and pasture for all the counties in Oregon. The data is not complete in every instance, but there are some surrogates that I think we can use. So, we're not dealing with irrigated cropland at all, or irrigation of any type, but we are looking at non-irrigated cropland and pasture. So these are the per acre figures that they have for each county. And they have some down below for Oregon cumulatively or other counties. I'm not sure what that exactly means, but there's some data that I think that we can use that's helpful. So I'm just going to run up to the beginning now. Here again, this sets the stage, what the purpose is, and walks us through some steps. Getting started, you want to identify identify the property area, and then you look at the soils, and you also determine what the use is, or what it's best suited for. And there's really two choices, right? It's either livestock grazing or cultivated agriculture. Then we want to inventory the soils, and then we get started, right? The time value of money. There's a series of steps, and they're different for grazing land versus cultivated land. You don't need to worry about what some of the stuff means. Just know that it does mean something, right? And so um, you apply a general economic contribution per farm of basically 56%. Identify the lease agreement, how long it is, apply calculation based on that feature, which is a table that shows how to do that. Livestock is a little different. The two big differences in the two categories is one, the dollar figure is going to be far lower for grazing, and the economic contribution is higher actually for grazing than cultivated agriculture, but the rest of it is the same. So you go through, um, um, identify the amount of the lease agreement, the years of the lease agreement, multiply that by your number above. It comes up with another number in dollars, and use that. Here's kind of the calculus to determine the time value of money. So depending upon the lease agreement duration, use this number. So you just saw before a couple of numbers and a couple of examples. The 873 number for cultivated agriculture. And this instance, it was a lease agreement of 30 years. So you multiply by this number, the 0.6533, which gives you this figure, the 570. And then you start calculating the actual mitigation responsibility. This efficiency factor is what helps us make a distinction in the different types of soils and their various different levels of productivity. So as you see, a class 3 soil is more productive than a class 5 soil, so the number's higher, right? So we're going to take this 570, 76 number, and where we've got class 3 soils, we'll multiply it by 1.75. And in the other example, the grazing example, where you've got class 6 soils, we'll just multiply it by 1. And that really it makes a difference between the soil capabilities. I actually think it's kind of a clever way to do that. And you just kind of walk through the rest of the way. There's an administrative cost feature that we would use. So again, where we ended up with the, 998.83 number above, multiplied by 1.2, which gives us that 1198 number. And then you apply those to each amount of soils in acres in each soil class. And that's straight arithmetic, right? If you got 62.3 acres of this at this amount equals this number. 915.3 of this at this number equals this amount. And the last thing you do is you add them all together, and that's where you go. You end up with a total mitigation responsibility of just a little below 1.2 million. um, in that instance, in that circumstance. That's, given if those numbers all add up right. Again, here's our table we looked at. There is a description of the different factors that we apply and how they came to be and what they represent. So I'm going to pivot here and actually go through an example. We'll take the methodology we just walked through. This is somewhere in a county far, far away. It's a random piece of property. Just for example purposes, this is the soils information where we use the NRCS soil data online soil service, and you'll see the mosaic, right? It was mentioned, the different soils patterns and kind of a tapestry there. I have just kind of walk through the steps. This is a 1,280 acre project area. It is best characterized as being used for cultivated agriculture, dryland agriculture. There's a table. I've just put you don't have to do this, but I've just kind of tabulated the soil stuff and information in that table. We'll talk about the amounts and characters and agricultural capability, and then kind of added it all up down here. And you notice there are some class 2 soils which are otherwise off limits, but in this instance, they're less than 5% of the total project area. So they're okay. It's a de minimis amount. Let's look at them real quick again. You also look at them. There are these little strips. That might be one there, maybe. And they're just kind of here and there. And they're not any, maybe right there, and not any uniform pattern. They're just sort of present there, which no distinguishing features, certainly not managed any differently. So then you end up with your amount. We've got 62 acres of class 2, 915 acres of class 3, 71% of the project. We have some class 7 soil. We don't count, right? We don't have to mitigate for class 7 soils, and so we don't need to worry about them. We're using the figures for cultivated agriculture. And so because there's no crop rent information for this county, which is some unknown county, we're using the $52 for other counties, unquote. And we know that when we multiply that by the agricultural economic contribution factor, we end up at $29.12. And if we know that the expected, in this case, let's just say we know the lease agreement is going to be 30 years long. So we multiply 30 by that number and get up to basically a per acre amount, 873. We bring that back to real time at a time value adjusted money by multiplying it by the 0.6533 figure in table 2. Again, if that was a 20-year duration or 25 or 35, that'd be a different number. But that comes up with the final feature here at 570.76. And then we go on to do our final calculations, right? So we've got, this really, I think, illustrates the efficiency factor, right? So it's the same number overall, but it's modified by the efficiency factor. So, and we know that class 2 soils are more productive than class 3 soils. So it's a higher number. And we come up when we apply those, efficiency factor 2 for class 2 soils, 1.75 for class 3 soils. Those are the two totals that we get on an acre basis. And then, whoops, doggone it. We multiply those numbers by our administrative cost figure, and that brings us here. So these 1369.82 and 1198.60. And then we, again, now we're just down to straight arithmetic. We've got 62.3 acres of class 2 soils multiplied by this number here, right? Gives us this overall number, 85. And same with the class 3 soils. Gives us this number, just around 1,100. And we just add them up, so in the not quite 1,000 acres that we're mitigating for, because some of it's class 7 that doesn't require mitigation. The overall amount is $1,182,419. And that is the amount that would be the payment that would go to the county or a stormwater conservation service or another entity that can receive and handle and reinvest those funds to provide uplift for the local agricultural economy. And I hope that makes sense.